Hello all, good morning. In today's class, we'll be discussing about AAIATC mathematics. The chapter we're going to focus on complex numbers and quadratic equations. So this class is purely focused on its concepts and formula revision. So many people have been asking before whether the new vacancy is coming or not. As of now, no official notification has been provided, but we can estimate that we can expect a notification on late 2024 or early 2025. So we can set a target that we have approximate 100 to 200 days till the next recruitment starts. Okay, so before that, I will finish the syllabus so we can start with the marathon question solution along with the mock test and okay. So let us start ahead with the class. Okay. So firstly, we're going to discuss about complex numbers. Okay. Complex numbers. Complex numbers. A complex numbers is written in the form of z is equal to x plus iy. Okay. Where is x denotes the real part of z and y denotes the imaginary part of z. Okay. Here I is called iota. Imaginary also called iota. Okay. What is the value of I? I equal to root of minus 1. Okay. This is important. This is also important. Okay. So let me write some properties of I. First of all, I wrote like I is equal to root of minus 1, right? And if we take the square, I square is equal to minus 1. I cube is equal to minus I. So I raised to 4 equal to 1. We need to know these values. Okay. Okay. Let's write some more properties of I. I plus I square plus I cube plus I raised to 4 equal to 0. Okay. This is one such important property. Another is that in a generalized way, I raised to n plus I raised to n plus 1 plus I raised to n plus 2 plus I raised to n plus 3 equal to 0. Okay. Next one is that I raised to n equal to 1 when n belongs to a multiple of 4. Multiple of 4. Okay. Or we can like this, like this. I raised to 4n equal to 1. Okay. This is also important. Okay. Now let us discuss about the algebra of complex numbers. Okay. Algebra of complex numbers. Okay. First of all, we are going to learn about addition and subtraction. Addition or subtraction. Okay. Let's say we have two complex numbers. Z1 is equal to x1 plus I y1 and Z2 is equal to x2 plus I y2. Okay. Then Z1 plus of minus Z2 is equal to x1 plus of minus iy1 plus or minus, that's plus for addition, minus for subtraction, plus of minus x2 plus of minus iy2. So we will be getting the final result like this. Z1 plus of minus Z2 is equal to, we had to write the real terms together, that is x1 plus of minus x2 plus of minus I of y1 plus or minus y2. So this is the result. Okay, that's it. So now let us discuss about multiplication of two complex numbers. Second one, multiplication. Okay. As we know, Z1 is x1 plus iy1, Z2 is x2 plus iy2. Then Z1 into Z2 is equal to, like this, x1 plus iy1 into x2 plus iy2. So after we open the brackets, we'll get the final result like this. Z1 into Z2 is equal to x1 into x2 minus y1 into y2 plus I of y1 x2 plus y2 x1. Okay, we don't need to study by heart, we just need to expand the brackets. Okay, that's it. I will also write the case for division. Third one, division. It will be like this. Z1 by Z2 equal to x1 plus iy1 by x2 plus iy2. So in order to do this, we must take the conjugate and multiply. What is the conjugate? Conjugate means taking the imaginary coefficient sign as negative. Okay, that is like this, x2 minus iy2 by x2 minus iy2. Okay, just changing the sign here of the imaginary term coefficient. So we'll get the result as like this. Okay, after expanding, we'll get the result like this: x1 x2 plus y1 y2 divided by x2 square plus y2 square. Okay, plus I of y1 x2 minus y2 x1 divided by x2 square plus y2 square. Okay, that you can write a note. Some properties of I. Okay, note. First one is 1 by I equal to minus I. Okay. Second one is 1 plus I the whole square is equal to 2I. Third one is 1 minus I the whole square is minus 2I. Okay. Fourth one is 1 plus I by 1 minus I equal to I. Okay. Now we are going to learn about modulus and conjugate of a complex number. So first of all, let us learn about modulus. Write the heading as modulus of a complex number. Okay. Modulus, we know that Z is equal to x plus iy, right? Then what is mod z? Mod z means it's modulus. Modulus is represented by mod z. So mod z is equal to root of x square plus y square. Okay. So here we know that Z is equal to real part of Z plus imaginary part of Z. So in this case, what is mod Z? Mod Z is equal to root of real part of Z square, the whole square, plus imaginary part of Z whole square. Okay. Next one is second one is, we know that Z is equal to minus, let's say Z is equal to minus x plus iy. Another form of complex number. Or we can write a complex number like this, x minus iy, z is equal to x minus iy. Or we can write like this, minus x minus iy. Okay, in all these cases, mod z remains the same. That is, the modulus of all these cases remain the same. That is root of x square plus y square. Okay. Now let us learn about conjugate of a complex number. What is it? Conjugate of a complex number. Conjugate of a complex number. Okay. Let z is equal to x plus iy. Okay. Conjugate is represented as z bar. Conjugate z bar. Then z bar is equal to x minus iy. Okay. Also, if z is equal to minus x minus iy, then z bar means changing the sign of this, the I part. Okay, this minus x plus iy. Also, what is this z bar? The whole bar. It returns to original, that is x plus iy. That's it. Okay. Now let us learn about some properties of modulus and conjugate. Properties. Write the heading as properties. This first one. Modulus of z1 into z2 is equal to mod z1 into mod z2. Okay. Second one. Modulus of z1 by z2 is equal to mod z1 by mod z2. Okay. Third one. Is modulus of z1 is into z2 divided by z3 equal to like this. Mod z1 into mod z2 divided by mod z3. Okay. Next one is z into z bar, which is equal to mod z square. Okay. Next one is z bar, the whole bar, is equal to z. Okay. Next one is z1 plus z2, the whole bar, equal to z1 bar plus z2 bar. Okay. The last one is z raised to n modulus is same as modulus of z the whole raised to n. We must need to know these properties in order to solve the problems. Okay. Now let us go to the next topic. I'm only revising important concepts and formulas. Okay, guys. In depth, if you want to learn, please go through the NCERT textbooks. Argand plane and polar representation. Argand plane is a plane consisting of real axis and imaginary axis. So I'm going to mark this as RA. RA means real axis. I'm going to mark this as IA, imaginary axis. And this plane is called the Argand plane. Argand plane. Okay. Let's say I have a point x comma x plus iy. Okay. So the point xy will be here. Xy. Okay. This is the origin. I'm marking this point. Okay. So the distance from here to here will obviously be y, and the distance from here to here will obviously be x, right? And there will be an angle theta here. Theta. This theta will be known as argument or amplitude. Okay. So what is this mod z? Mod z is this one as per hypotenuse theorem, which is equal to root of x square plus y square. Okay. Similarly, if we have like x minus iy, the point will be somewhere around here, x comma minus y. If you're drawing like this, it will become like this. Similarly, the argument theta will be like this. Okay, so also this case also modulus remains the same. That is mod z is equal to root of x square plus y square. Okay. Suppose if you want to mark z is equal to minus 2 plus 3i on the arcane plane, it will be like this. Minus 2 will be here, 3 will be here, 3 will be here. So this will be the point, minus 2 comma 3. See, like that. Okay. Now let us learn about polar form. Okay, now we have learned about arcane plane. Now let us learn about polar form. Polar form. Okay. For polar form, we know that in general expression z is equal to x plus iy. The polar form is given as z is equal to mod z, which is the modulus, into cos theta plus I sin theta. Okay. This theta is called the amplitude or argument, as I mentioned before. But can be mentioned as amplitude of z or argument of z. Okay. Next one is for theta. For theta, first condition, when z belongs to first quadrant, what will be the value of theta? Okay, when z is belonging to the first quadrant, what will be the value of theta? Theta is simply as tan inverse y by x. Okay. Second one, when z belongs to second quadrant, when z is belonging to second quadrant, then theta is equal to pi minus tan inverse y by x. Okay. Third one, when z belongs to third quadrant, then theta is equal to pi plus tan inverse y by x. Okay. Fourth one, when z belongs to fourth quadrant, theta is equal to 2 pi minus tan inverse y by x, or theta is equal to minus tan inverse y by x, and we can only use this formula when it is on basis of clockwise rotation. Clockwise rotation. Okay. PDF won't be provided, everyone. Please go through the videos one by one and write down notes of your own. That's enough. Okay. Now let us move on to the next topic. Complex numbers. All concepts of complex numbers have been covered. Now we are going to move on to the next topic, which is called quadratic equations. Okay. Quadratic equation. Okay. So quadratic equation is of the form ax square plus bx plus c. Okay. A should never be equal to 0 since it is the leading coefficient. Leading coefficient. Okay, first of all, we need to know the roots, or called zeros, or called solutions of the quadratic equations. They are denoted as alpha and beta. That is x minus alpha into x minus beta equal to 0. X equal to alpha comma beta are the roots. Okay. If the roots, that is if alpha and beta are given, that is if the roots are given, then we can find the equation by putting like this: x minus alpha into x minus beta is equal to 0 and solving it. Okay. Or we can get the equation with the help of alpha and beta if we know this particular equation. Okay, x square minus alpha plus beta of x plus alpha beta equal to 0. The equation will be in this form. Okay. Also, entrance point. Okay, let ax square plus bx plus c equal to 0. Then alpha plus beta equal to minus b by a, and alpha beta is equal to c by a. Okay. Okay. Now let us learn about the conditions for quadratic equation. Conditions for solutions, that is ax square plus bx plus c. First condition is mainly for a greater than 0. First of all, we have to find the discriminant. That's d is equal to b square minus 4ac. Okay. If d is greater than 0, then what happens? If d is greater than 0, then we get a real and distinct root. Real and distinct root. That is, alpha will not be equal to beta. Then the graph will be like this: x and y, where this point will be alpha comma 0 and this point will be beta comma 0. Okay, this is the first condition. Second condition is d equal to 0. When d equal to 0, what happens is that we get equal roots, which means that we get alpha equal to beta, and we get like a perfect square quadratic equation. We get a perfect square quadratic equation. Then the graph will look like this. Okay, will touch at one point where this point will be alpha equal to beta. Okay. Third condition is when d is less than 0, then we get no real root exist. No real roots will exist. At that time, the graph will be like this. That is, there is no real part, so it will be like this. Okay. Now let me just draw the graph for the conditions. Main condition will be like a less than 0. Okay. Sub condition 1 will be like d greater than 0. At that time, the graph will just turn ulta. Like this will be for d greater than 0, and for d equal to 0, the graph will be like this, just the mirror image. Okay. And for d less than 0, the graph will be like this. Okay. Okay. Now we'll just learn the next topic called cube roots of unity. Cube roots of unity. Okay. Cube roots of unity are denoted as omega and omega square. Omega square. Let's say we have x cube is equal to 1. X cube minus 1 cube is equal to 0. That is x minus 1 into x square plus x plus 1 equal to 0. Okay. So we have three values of x. So one is x equal to 1. Another is x x square plus x plus 1 equals 0. By the finding factorization and all, we get the value of x as two values, minus 1 plus root 3 I by 2 and minus 1 minus root 3 I by 2. This is omega and this will be omega square. Okay. Now let us write down some properties of cube roots of unity. Okay. First property is 1 plus omega square equal to 0. Okay. Second property, omega bar equal to omega square. Third property, omega bar square equal to omega. Fourth property, mod omega equal to mod omega square equal to 1. Fifth property, omega cube equal to, okay, that's it about cube roots of unity. Now let us write a small entrance point regarding complex numbers. Okay, that is called Euler form. Euler form. Okay, that is if z is equal to mod sine mod z is equal to mod z of cos theta plus I sine theta, then in Euler form, z will be r into e raised to I theta. This will be the Euler form. Okay. Similarly, if z is equal to mod z into cos theta minus I sin theta, then its corresponding Euler form will be z is equal to r into e raised to minus I theta. Okay. These are important, guys. Please note it down. So this is it about the theory part of complex numbers and quadratic equations. I have discussed all the important formulas related to quadratic equations as well as complex numbers. Hope you all go through it. In the next class, we'll be discussing about the different types of problems that can come in this chapter. So hope you all go through this one by one and have a nice day.